Hello my dear students, welcome to my YouTube channel, that's Concepts of Chemistry. Before starting today's lecture, please do subscribe my channel. My dear students, today I am going to solve some numericals on the photoelectric effect which we have done in the previous class. So let me write down the formula which we are going to use for solving the numericals. So here I am writing the formula of the photoelectric effect, and it is the energy of a photon that strikes the metal surface is equal to the work function of that metal plus kinetic energy, the maximum kinetic energy that an electron will acquire after ejection. Now, the energy of a photon is represented by a formula h nu, where h is a Planck's constant and nu is the frequency, which is equal to the h nu naught. Again, h is a Planck's constant and nu naught is a threshold frequency, and we all know what's the formula of kinetic energy. It's half m v square, where m is the mass of electron, v is the velocity of electron. Now this formula can also be represented like h c by lambda, where c is the speed of light, lambda is the wavelength of the light that have been used for ejecting the electron, that is the wavelength of photon. Was work function, it's h c by lambda naught, where lambda naught is a threshold wavelength, the maximum wavelength that a photon must acquire to cause the photoelectric effect, plus half m v square. So these are the formula that we are going to use for solving the numericals. So now let's come to the very first numerical. The very first numerical is saying the minimum energy required to overcome the attractive force between the electron. The minimum energy required to overcome the attractive force between an electron and the surface of silver metal is 5.52 into 10 to the power minus 19 joules. Now it is a minimum energy required, so this minimum energy will be called as work function for the silver metal. It's the work function for the silver metal. So the work function is represented by phi. It is equal to the 5.52 into 10 raised to power minus 19 joules. Now further question is asking what will be the maximum kinetic energy of electron ejected out from silver. We have to evaluate the kinetic energy maximum of the electron. What will be the maximum kinetic energy of electron ejected from silver which is being exposed to a UV light of wavelength is 360 angstrom. This is the wavelength of the photon that we are using to cause the photoelectric effect. So I'm writing first of all the formula. Before that, firstly convert this 360 angstroms to the meters, because we always solve numericals in the SI units. So it is 360 into 10 to the power minus 10 meters. So this is the wavelength. Now let me write down the formula. The energy of a photon will be equal to the phi plus kinetic energy maximum. Now energy of photon is h c by lambda, that will be equal to the phi plus kinetic energy maximum. So let me substitute the values of every constant and the given values. So what is the value of Planck's constant? It is first of all 6.626 into 10 to the power minus 34. What's the speed of light? The c, it is 3 into 10 raised to power 8 divided by What is the value of wavelength? It is 360 into 10 raised to the power minus 10, which is equal to the phi. Phi, the value of phi is given. It is 5.52 into 10 raised to the power minus 19 plus kinetic energy that we have to evaluate. So after solving the energy of photon, that is hc by lambda, we got its value to be 5.52 into 10 raised to the power minus 18, which is equal to, let's convert the value of phi in terms of 10 to the power minus 18. So it comes out to be 0.552 into 10 to the power minus 18 plus kinetic energy. Now 5.52 into 10 to the power minus 18 minus 0.552 into 10 to the power minus 18 comes out to be the kinetic energy maximum. So kinetic energy maximum evaluates to 4.968 into 10 raised to the power minus 18 joules. So this is my answer. So hopefully, my dear students, you got the first numerical. It was a very easy one. Please do have a look. Okay, now let's move to the second numerical. So this is the second numerical. The question is saying when the light of 470 nanometer falls on the surface of potassium metal. So first of all, the light of 470 nanometer, it is the wavelength of the photon given. So the wavelength of photon lambda, it comes out to be 470 nanometers. Let's convert it to SI unit. It comes out to be 470 into 10 to the power minus 9 meters. So question is saying when the light of 470 nanometer falls on the surface of potassium metal, the electrons are emitted with a velocity of 6.4 into 10 to the power 4 meter per second. So the velocity of electron comes out to be 6.4 into 10 raised to the power 4 meters per second. So further question is asking what is the minimum energy required to remove 1 mole of electrons from potassium metal. Means it's asking for the minimum energy required. Minimum energy stands for work function. The question is asking about the work function of the metal and for 1 moles of electrons. So let us calculate firstly the work function for the 1 electron. Then we are going to multiply that work function with the Avogadro number, because 1 mole stands for Avogadro number of electrons. You will get the answer. So let me write the formula again. It comes out to be energy of photon will be equal to the phi plus kinetic energy of electron, the maximum value of kinetic energy. Now energy of photon stands for the hc by lambda is equal to phi. We have to evaluate. What's the formula for kinetic energy? Is half mv square. Now velocity is given. The mass of electron is equal to the 9.1 into 10 raised to the power minus 31 kilograms. So now let's substitute all the values in the formula. So what's the value of Planck's constant? It's 6.626 into 10 to the power minus 34. What's the value of speed of light? It's 3 into 10 raised to power 8 divided by, what's the value of wavelength? It is 470 into 10 raised to the power minus 9. It is equal to the phi plus half. What's the value of m? It's 9.1 into 10 raised to the power minus 31 into, what's the given velocity? It's 6.4 into 10 to the power 4 whole square. So the energy of photon, it comes out to be 422 into 10 to the power minus 21. It is equal to the phi. The kinetic energy comes out to be plus 1.864 into 10 to the power minus 21. So my phi comes out to be, the work function of one electron comes out to be 420.136 into 10 raised to the power minus 21. So this is the work function of one electron. This is the work function of one electron. We have to evaluate the work function for 1 mole of electron, because in question he has asked about the 1 mole. So I am writing phi of 1 mole of electron. It will be equal to the phi of 1 electron, means work function of 1 electron, into Avogadro number of atoms, or Avogadro number, sorry, is just Avogadro number of electrons. So you will get the work function of 1 mole of electron. So Avogadro is the number of units the 1 mole will have, whether it's for molecule, whether it's for electron, whether it's for proton, anything. So the work function of 1 electron comes out to be 420.136 into 10 raised to power minus 21. What's the value of Avogadro number? It's 6.022 into 10 raised to power 23. So work function of 1 mole of electrons comes out to be 2530 into 10 to the power 2. 2530 into 10 to the power 2 joules, or you can simply write 253 kilojoules. So that's my answer. Hope you got this numerical also. Please do have a look. Now let's move to the third numerical. Now what's the third numerical is saying? When a certain metal was irradiated with a light of frequency 3.2 into 10 to the power 16 Hz, the photoelectrons emitted had twice the kinetic energy as did the photoelectrons emitted when the same metal was irradiated with the light of frequency 2 into 10 to the power 16. Calculate the threshold frequency, the nu naught for the metal. So let us talk about two cases. This is the case number 1. So it will be the frequency number 1, and this is the frequency number 2. So I'm writing my case number 1. The frequency number 1 comes out to be 3.2 into 10 raised to the power 16 Hertz. Now case number 2, frequency number 2 comes out to be 2 into 10 raised to the power 16 Hertz. Now the photoelectrons emitted had twice the kinetic energy as did the photoelectrons emitted when the same metal was irradiated with the light of frequency number 2. So that means the kinetic energy of first case will be equal to the twice the kinetic energy of second case. Now in the first case, the photoelectron emitted had twice the kinetic energy of as the photoelectrons emitted when the same metal was irradiated with the frequency number 2. So kinetic energy of first case will be twice the kinetic energy of the second case. So it will be kinetic energy 1 will be equal to the 2 into kinetic energy 2. And here we have to evaluate the threshold frequency. So this is the question, the given values I have written. So let us understand it. Let me do a derivation for you first. This thing comes out to be energy of photon, let me write the formula first. It will be equal to the phi plus kinetic energy. Now energy of photon is h nu. The threshold energy will be h nu naught, the threshold energy or the work function. So it comes out to be h nu naught plus kinetic energy. Now h nu minus h nu naught will be equal to the kinetic energy. Now let me take a h constant over here. It comes out to be nu minus nu naught equal to the kinetic energy. Now make this formula in two cases, the case number 1 and case number 2. Here it will be h, the frequency number 1, minus nu naught, that will be equal to the kinetic energy number 1, and here h nu 2 minus nu naught will be equal to the kinetic energy number 2. So mark it as number 1 and mark it this as number 2. Now let us divide number 1 by number 2. It comes out to be h nu 1 minus nu naught equal to the kinetic energy number 1 divided by h nu 2 minus nu naught, and it will be kinetic energy number 2. Here what will happen? This h and h will be cancelled. Now this is the case that kinetic energy 1 is equal to 2 times into kinetic energy number 2. Now let's substitute this value over here. It comes out to be nu 1 minus nu naught divided by nu 2 minus nu naught. It will be equal to the 2 into kinetic energy 2 divided by kinetic energy 2. Here this will be cancelled. Now nu 1 minus nu naught will be equal to the 2 into nu 2 minus nu naught. It comes out to be nu 1 minus nu naught equal to the 2 into nu 2 minus nu naught. Now hold on, it's 2 nu naught, sorry. Now it will be 2 nu naught minus nu naught will be equal to the 2 nu 2 minus nu 1. So it comes out to be nu naught will be equal to the 2 into nu 2 minus nu 1. Now the nu 2 and the nu 1 is given in the question, frequency number 2 and frequency number 1 is given in the question, and we have to evaluate the threshold frequency. So what's the value of frequency number 2? It is 2 into 10 to the power 16 hertz. It is 2 into 10 to the power 16 hertz. What's the value of frequency number 1? You can see that it's 3.2 into 10 to the power 16. It's 3.2 into 10 to the power 16. This comes out to be 4 into 10 to the power 16 minus 3.2 into 10 to the power 16. My threshold frequency comes out to be 0.8 into 10 to the power 16, or you can say 8 into 10 to the power 15 hertz. So that's the threshold frequency. I hope you got this derivational numerical. It was the easy one. So now let's move to the numerical number 4. Now what numerical number 4 is asking? If the photon of wavelength 150 picometers strikes on an atom and one of its inner bound electron is ejected out with a velocity of 1.5 into 10 to the power 7 meter per second. This is the velocity. This is the given wavelength in the question. Calculate the energy with which it is bound to the nucleus. Means it is asking about the threshold energy, or in simple words, the question is asking about the work function. The question is asking about the work function of the metal. We have to evaluate phi. The work function is also called threshold energy. Please don't get confused. Now, the wavelength given is 150 picometers, and in SI unit comes out to be 150 into 10 to the power minus 12 meters. The velocity is given to be 1.5 into 10 raised to power 7 meters per second. What's the mass of electron? It's 9.1 into 10 raised to the power minus 31 kilograms. And we have to evaluate the work function. So let me again write the formula. The energy of photon will be equal to the phi plus kinetic energy. Now, energy of photon is h c by lambda. It is equal to the phi plus kinetic energy is half m v square. Now let's substitute all the given values in the formula. What's the value of Planck's constant? It's 6.626 into 10 to the power minus 34. What's the value of speed of light? Is 3 into 10 raised to power 8 divided by, what's the wavelength given in the question? It's 150 into 10 raised to power minus 12 meters, which is equal to the phi plus 1 by 2. What's the value of m over here? It's 9.1 into 10 to the power minus 31. And what's the velocity given in the question? It's 1.5 into 10 raised to power 7 square. Now, the energy of photon after evaluation comes out to be 13.25 into 10 raised to power minus 16 joules is equal to the phi. The kinetic energy comes out to be plus 1.025 into 10 raised to the power minus 16. So here phi, it comes out to be 12.225 into 10 raised to power minus 16 joules. So that's the work function of the metal, or the threshold energy, or a work function. So we got it. So please do have a look. Now let's move to the fifth numerical, threshold wavelength. Question number 5th. The threshold wavelength of a metal is 230 nanometers. The word was threshold wavelength. That means in question lambda naught is given. What will be the kinetic energy of photoelectrons ejected when the metal is irradiated with a wavelength of 180 nanometer? So this is a wavelength of photon that have been used for causing the photoelectric effect. So first of all, the threshold wavelength is 230 nanometers. In SI, it comes out to be 230 into 10 to the power minus 9 meters. Now lambda, it is 180 nanometers, and it comes out to be 180 into 10 to the power minus 9 meters. In the question, he is asking what will be the kinetic energy of the photoelectrons emitted. We have to evaluate the kinetic energy of the electron that have been emitted. Okay, so let me write the formula. The energy of photon will be equal to the phi, that is work function, plus kinetic energy of the electron that have been emitted. So it comes out to be energy of photon is h c by lambda. The work function is h c by lambda naught plus kinetic energy. Uh, Now hc by lambda minus hc by lambda naught will be equal to the kinetic energy. Now what next? H into c, I have taken h and c common. It comes out to be 1 by lambda minus 1 by lambda naught, that will be equal to the kinetic energy. So now let's substitute all the values. First of all, what is the value of h? Planck's constant. It's 6.626 into 10 to the power minus 34. What's the value of c? It's 3 into 10 raised to power 8. Now, what's the value of wavelength of the photon? It's 180 into 10 to the power minus 9. 180 into 10 to the power minus 9. And what's the threshold wavelength given in the question? It's 230 nanometer, means 230 into 10 to the power minus 9. It is equal to the kinetic energy. So now let's take 10 to the power plus 9 common. This comes out to be 6.626 into 10 to the power minus 34 into 3 into 10 raised to power 8 into 10 raised to power plus 9 common. It is now divided by 180 minus 1 by 230 bracket close. It is equal to the kinetic energy. So here, after evaluation, the kinetic energy of electron comes out to be 2.4 into 10 raised to the power minus 19 joules. So this is the kinetic energy of the electron that have been emitted when a photon strikes the metal surface. So these all were the numericals that I had done in the today's live class. Hope you all understood all the numericals of the today's lecture. If any student wants to book a paid one-to-one online class to clear their doubts, then she can contact me. My phone number is mentioned on thumbnail of this lecture. Please like, subscribe and share my channel to maximum number of students. Don't forget to press the subscribe button. Stay blessed.